Hello again. Welcome to another lesson in geometry. Today we're covering section 6-6, trapezoids and kites. Okay. All right, so we have some vocabulary. Underline the correct word to complete each sentence. An isosceles triangle always has two congruent sides. Remember, it could have three, but it must have at least two. An equilateral triangle is also an isosceles triangle because it has two congruent sides. Okay, so cross out the links that cannot be side links of an isosceles triangle. So 3, 4, and 5 we'd have to cross out. They are not two the same. This one's good. Two 8s are in there. This one's good. That has two 3.6s. And our last one is good. We have two 11s. Okay. All right, we have a definition here. A trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So this time we say exactly. So a parallelogram is not a trapezoid. Okay. So parallel sides of a trapezoid are called its bases, and the non-parallel sides are called the legs. So two angles that share a base of a trapezoid are called the base angles. Okay. So these are our parallel sides. They're in purple. And the other two sides are not parallel. They're in red, and they don't have to be perfect like this. They could be one standing at different angles. It doesn't matter. Okay. And the base angles are the ones that touch the bases. So the bases are the parallel sides. So cross out figure that is not a trapezoid. So let's see. This guy's a trapezoid. We have these two lines being parallel. This guy's a trapezoid. We have these two lines being parallel. The last one is a trapezoid. We have these two lines being parallel. And this one's not a trapezoid, not because we don't have opposite sides parallel, but because it's not a quadrilateral. Okay. So circle the figures that can be divided into two trapezoids, and then divide each figure that you circled into two trapezoids. So I can't think of a way to divide this into two trapezoids. If I cut it across here, I'm not going to get parallel lines. So let's see. I could maybe do this to get it parallel to this one. I could put one here, but then I'm going to have a triangle and a trapezoid no matter which way I do it. So cross that guy off. Let's see. Same with this. If I have this one here, I have to go parallel. So I could go maybe parallel here. I think that looks parallel. But then I have a triangle up top. And the same happens no matter which way I do it. This one I can. If I split across here, then this red and this one's parallel. So there's one trapezoid up top, green, and then there's another trapezoid down here in blue. And in our last one, we can do it also. We have parallel lines, so we're just going to split it weird. And then this blue one is a trapezoid, and the red one over here is also a trapezoid. So we can circle this one. All right, let's flip it over and check, see what's on page 2. Okay, on our second page, we have another set of theorems about trapezoids this time. So if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So that's our first theorem. And we need to talk about what an isosceles trapezoid is. So this is isosceles triangle. These two sides are the same. An isosceles trapezoid is just going to go somewhere up in the middle of this triangle and cut off the top. Okay, so now these two are parallel, and what's left on the base, non-base sides, the leg sides, are still going to be the same. So think of it as an isosceles triangle that had the top lopped off of it. Okay. All right. So if a and we have one more theorem here, 620. If a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. Okay. So that means the diagonals that cut from here to here and here to here are going to be the same. So number 6 says, if TRAP is an isosceles trapezoid, this is a picture of it here, and it has bases RA and TP, that's why those two are set parallel, then angle T should be congruent to angle P, and that's because each pair of base angles are going to be the same. So that marks this angle and this angle the same. And angle R and angle A should be the same. Now, they're not going to be the same as T and P, but they're going to be the same as each other. Okay? So use theorem 6-19 in your answers from exercises 6 to draw the congruence marks on the trapezoid at the right. And we've already done that. So we marked T and P congruent and R and A congruent. All right, so if shape ABCD is an isosceles trapezoid, then AC should be congruent to CD. So here's our isosceles trapezoid. These are the two bases. And remember, on an isosceles trapezoid, the legs should be congruent. That's what those little marks are for. So if AC and is going to be congruent to BD here. Okay, so this is because our diagonals are going to be the same. That was theorem 6-20. So if you have an isosceles trapezoid, the diagonals are going to be the same. So AC will be congruent to BD. If ABCD is an isosceles trapezoid and AB is 5, then CD should also be 5. And that's because the legs of the isosceles trapezoid are always congruent. So use theorem 6-20 in your answer from exercise 8 and 9 to label the diagram at the right. So we have marked the diagonals not as congruent in here. So the blue one should be the same as each other. So this blue one and this black diagonal should be congruent. Okay, and then these legs should be congruent. All right, theorem 6-21, trapezoid mid-segment theorem. If a quadrilateral is a trapezoid, then number one, the mid-segment is parallel to the bases. And number two, the length of the mid-segment is the sum of the lengths of the bases. So first off, we need to talk about what a mid-segment is. Okay, so we have a trapezoid. Okay, remember it's a trapezoid because I have exactly one set of parallel lines. Okay, all right, and so if I go through the middle and I go down this side over here, and I find its middle, so I find the midpoint. Okay, and then I come over here and I do the same thing, and I find the midpoint. The mid-segment is the connection of those two midpoints. And that mid-segment is going to be parallel to both bases. So it'll be the same. So this guy is my mid-segment. Okay. And that means the way I built it was to make these two the same and these two the same by splitting it in half. Okay. All right, so the mid-segment is parallel to the bases, and the length of the mid-segment is half the sum of the lengths of the bases. So if TRAP is a trapezoid with mid-segment MN, then MN is going to be parallel to RA, and that will also be parallel to TP. It's going to be parallel to the bases. And the length of MN is going to be the length of RA plus the length of TP. So we can add up the bases and then divide it by 2 and get the length of the mid-segment. It's kind of like averaging the bases. Okay, in problem number 2, we have finding angle measures in an isosceles trapezoids. Okay, so this is I got it. So we have a fan here, and the fan has 15 angles meeting at the center. And those are all going to be congruent angles. And what are the measures of the base angles of the congruent isosceles trapezoids in the second ring? So basically, we're looking for the base angles in one of these trapezoids. All right. So use the diagram at the right for exercises 12 through 16. It says first, circle the number of isosceles triangles in each wedge. So let's see, we can count them. So there's 1, 2, and 3. So there are 3 of them. And then it says underline the number of isosceles trapezoids in each wedge. So let's count those. So we have 1 isosceles trapezoid here. We have a second one here. And we have a third one that combines the 2 of them. So there should be 3 of those. Okay. All right, number 13 says find the measure of angle A in the little wedge here. Okay. All right, so the whole wedges all together make 360. So there are 360 degrees, and then there are 15 little wedges. Oops, didn't mean to scratch that out and to underline it. And if you divide 316 by 15, you get 24 degrees for each one of those little wedges. All right, now we have an isosceles triangle formed from these wedges. So we have a 24 up top, and then we know these two angles across from the congruent sides have to be congruent also. So remember, a whole triangle is 180, so we'll subtract off the 24 we used for the top, and then divide it equally, because our bottom two angles should be equal. So 180 minus 24 divided by 2 will give us 78 for each of those little base angles in our isosceles triangle. All right, so C, well, that could be B here. So B is 78. C and B are going to be supplementary. They form a linear pair there. So to get C, I do 78 subtract from 180, which would give us 102. Okay. And then remember, in an isosceles trapezoid, C and D are going to be supplementary, and that's because we have parallel lines, and those are same side interior. Same side interior are going to be supplementary. So 180 minus the 102 will give me 78 for D. So the base angles on my bottom wedge are going to be 102 for C and 78 for D. So 78 and 102. All right, let's flip it over and look at our third page. Okay, in problem number 3, we have using the mid-segment theorem. So this is a got it problem. So we have some algebra in this one. So we have MN is the mid-segment of PQRS. Okay, so mid-segment means we're going to have this is equal and this is equal. Okay, so it cuts the two sides in between into congruent parts. Okay, so what is the value of x? So the value of x could be found by doing this. Mn is going to be equal to half of the two bases. So this base and this base added up, divided by 2 should make the green one in the middle, the mid-segment. So since Mn is our mid-segment, it should be equal to half of QR plus PS. Okay, and what's the reason for that? That's the trapezoid mid-segment theorem. Okay. All right, so then we're going to plug in some stuff here. So we're going to substitute 2x plus 11 for Mn. And then we're going to substitute 10 for QR, and we're going to substitute 8x minus 12 for PS. And this is just a substitution property. So we're just doing a substitution. Substitution. Okay. All right, and then we're going to simplify a little bit. So first we're going to simplify the inside here, combine our like terms. So we're going to put the 10 and the negative 12 together. Okay, and then the next step, they times the 1/2 to the stuff in the parentheses. So that was the distributive property. Okay. Let's see, and then they move the 1 to the other side, so that's add 1 to both sides. So that's addition property of equality. Okay, and then we're going to subtract 2x from both sides. And once again, that's the addition property of equality. And then we're going to divide by 2 to both sides. And that's our division property of equality. All right, so use the value of x to get what Mn is. So we're going to replace x in our formula. So this will become 2 times 6 plus 11, which is 12 plus 11 for 23. So we have a new definition here. A kite. So a kite is a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. So two pairs of consecutive sides congruent and no opposite sides congruent. So theorem 6-22, if a quadrilateral is a kite, then its diagonals are perpendicular. So if ABCD is a kite, then AC should be perpendicular to BD. Okay, so the diagonals are going to be perpendicular. So use theorem 6-22 and exercise 20 to draw congruence marks and right angle symbols on the kite. So a quadrilateral is a kite if its diagonals are perpendicular. So I can put my perpendicular mark there. And from our definition, a kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So here's one pair of consecutive sides congruent. Opposite of this AD is going to be BC, so they cannot be congruent, but BC and CD must get our second pair of congruent sides, consecutive congruent sides. All right. Problem number 4, finding angle measures in kites. So quadrilateral KLMN is a kite where the measure of angle 1, measure of angle 2, and the measure of angle 3 we need to find. So diagonals of a kite are perpendicular, so I know right away that angle 1 is going to be a 90. Okay, otherwise my diagonals wouldn't be perpendicular. So triangle KNM is going to be congruent to triangle KLM. So these two triangles, the one in blue and the one in green, are going to be congruent to each other. So by SSS, that's because we already marked the sides, and then we have the one that goes in between. So that's going to be reflexive to get that there. And then the measure of angle 3 is going to be equal to the measure of NKM, which is 36. So both of those have to be 36. All right, and then the measure of angle 2. So let me do some erasing here. Okay. So we have this little blue triangle in here, and we can extend out one of the sides to make an exterior angle. So the measure of angle 2 is going to be equal to, well, let's see. So we should really say it this way first. The measure of angle 1, the exterior angle, is going to be equal to the measure of the two remote interior angles, 2 and 3. So 2 would be equal to the measure of angle 1 minus the measure of angle 3. Okay. So the measure of angle 2, we don't know yet, but we know angle 1 is 90 and angle 3 is 36. So 90 minus 36 is going to give me 54 for the measure of angle 2. So now we have all three. We have 90 because the diagonals have to be perpendicular. We have 36 because the two triangles are congruent, and those are corresponding parts. And we have 54 by using the exterior angle theorem, although you could have just used the blue triangle by itself, in which case you knew the 36 and the 90, so you could have subtracted from 180 to get the extra angle 2. All right, let's flip it over. And on the back side, we have our lesson check. As always, pause the video, try your lesson check yourself, see if you can get all the checks and the X's in the right spot, and then turn it back on and check and see if you did it right. All right, welcome back. So our lesson check this time was a do you understand? And we're going to compare and contrast how kites and rhombuses are similar and different. So to help me explain, I have a kite and a rhombus drawn over here on the right side. So first off, quadrilateral. Both of them are quadrilaterals. Okay. Secondly, perpendicular diagonals. And this is also yes. Okay. So if we draw our diagonals in, one of them is here and here. Here and here. In both cases, we're going to end up with perpendicular. Okay. All right. Each diagonal bisects a pair of opposite angles. Okay. Well, this is going to be true for a rhombus. That's part of the definition of a rhombus. So, like this diagonal is going to bisect here and here and here and here, and all of them are going to be equal. And this diagonal is going to bisect here and here. And here and here, they're not going to be equal to each other, but they're going to all four of them will not be equal, but the pairs are equal. But when you go the other way, it doesn't work. Okay? So I have congruent opposite sides. Well, for a rhombus, yes, because all the sides are congruent. For a kite, no, the opposite sides are different lengths. Two pairs of congruent consecutive sides. For a rhombus, yes, because all the sides are congruent, so the consecutive sides will definitely be congruent. And for a kite, yes, we have these two up top and these two down below that are consecutive and congruent. Two pairs of congruent opposite angles. A rhombus, yes. Kite, no. Okay, the opposite angles going side to side here are going to be congruent, but up and down are not. Okay, in my kite. So supplementary consecutive angles, no for a kite, yes for a rhombus. Okay, so how is a kite similar? So the similar is going to be, let's see, they're both quadrilaterals, they both have perpendicular diagonals, and they both have two pairs of congruent consecutive sides. So how are they similar? So they are similar because they are both quadrilaterals with perpendicular diagonals, and two pairs of consecutive congruent sides. Okay. Now, how are they different? Well, they're different lots of ways, a lot more ways than that. So they're different because each diagonal bisects a pair of opposite angles. That's not true in both. And they're different because the congruent opposite sides is not true in both. And they're different because two pairs of congruent opposite angles is not true in both. And they're different because supplementary consecutive angles is not true in both. So there's a lot of stuff to put on here. So the difference here is kites have no opposite sides. Okay, congruent, that's one thing, comma. They have only one pair of congruent opposite angles. That's another thing. And they have no supplementary consecutive angles. All right. Check off vocabulary words that you understand. So hopefully you've got a trapezoid now. Remember, that's one set of parallel lines only. Okay. Kite. Okay. A base. We have bases in our trapezoid. We have legs, and we have a mid-segment. All right, so how well can you use the property of trapezoids and kites? As always, if you're not up here, watch the video again. Take some better notes and think about it as you go. It really will help you as we get towards our test coming up very soon. Okay, see you in class next time.